See, in this question, this is a ring of mass 2 kg and radius 0.5 meter, and it is rolling without slipping on this horizontal plane with a velocity of 1 meter per second in this direction. There is a small ball of mass 0.1 kg which is moving with a velocity of 20 meter per second in this direction, and after striking this ring over here at a height of 0.75 meter from the ground, it starts moving in vertical direction with a velocity of 10 meter per second. Now immediately after the collision, we have to find the correct options from these four. So let's see when this ball will going to collide over here on this ring, it will going to impart an impulse to this ring in this direction over here. This will be the direction of impulse which will be imparted by this ball on this ring. So one component of this impulse will going to come in downward direction like this, which will going to make the normal force over here an impulsive force. Now this ring also has a tendency of slipping, so the friction force which will be acted on this ring will going to become impulsive, as normal is impulsive and there is a tendency of slipping. So there will be an external impulsive force acting on the system of ball and ring over here. Okay, now in first option it is saying the ring has pure rotation about its stationary center of mass. See, about the center of mass, this ring will going to have a rotatory motion. Why? One component of this impulse will be in this direction and the friction will be acting towards left, because this ring will going to have a tendency of slipping towards right due to this impulse. So the friction will be acting towards left like this. I can show you over here. This will be the direction of friction force over here. Okay, so this component of impulse will going to rotate this ring about its center of mass in this direction, that is clockwise direction, and this friction force will also go to rotate this ring in clockwise direction. Hence this ring is having an external torque in clockwise direction which will going to rotate this ring in clockwise direction. So this ring will going to have a pure rotatory motion about its center of mass. Now it is saying that the center of mass is stationary over here. Okay, it is saying that the center of mass is stationary. Now if I will going to assume this friction to be non-impulsive over here, this is the glitch in this question, that if I will going to assume this friction to be non-impulsive over here, I can conserve the momentum. And what I can write? Initial momentum of this system. So initial momentum of ball is over here, its mass 0.1 kg into its velocity, that is 20, plus mass of ring, that is 2 kg, and its velocity, it is in negative direction, -1. This will be equals to final velocity of ball. See, I am conserving this momentum in x direction, so final velocity of ball in x direction is 0, plus let us say the velocity of this ring becomes v over here. Okay, so from here this will be 2 and this will be -2, this will be equals to 2 into v, so v will come out to be 0. Means my center of mass of this ring has stopped over here, it becomes stationary. But as I can see that the friction over here, it is impulsive in nature, so I cannot conserve this momentum over here. But assuming this friction not to be impulsive over here, I can conserve the momentum. Hence this is a possibility over here. So IIT has given answer A over here. So A is a possibility, I cannot deny it over here. Okay, now moving to B, the ring comes to a complete stop. See, I have seen over here that the ring is rotating, it hasn't come to a complete stop over here. So B option will be wrong, because ring is in rotatory motion over here. Now moving to C, friction between the ring and ground is towards left. As I have seen, this ring has a tendency to slip towards right, so friction over here is towards left. So this is correct over here. C option is correct. And in D it is saying there is no friction between the ring and the ground. So as I can see, there is friction, so D option will also be wrong over here. So my answer to this problem will be A, C, or you can say just C. Okay, these are my answers, because there is glitch in A option, so these are my answers over here. I hope you have understood this. Thank you very much.